Hello guys, I'm back. So sorry, my internet uh, was like hanging for some reason. So this this should work 100%, hopefully. Yeah, we have submitted it. Thank God we did. Thank God we did. Oh my God, that took us 40 minutes. I thought it would like take 10 minutes or something. Uh, After this, I was doing some other problem. Uh, where is that driver sheet? Driver. Hmm. Sliding window. Yeah, this one I was doing medium problems. This I was doing this problem, right? I couldn't really solve this. Longest repeating character replacement. Hmm. Binary subarrays with some given a binary array nums and an integer goal return the number of non-empty subarrays. What do you mean non-empty subarrays? And return what? The number of non-empty subarrays. We have to return not the size of it this time. We have to return the number of non-empty subarrays. All right. Uh, the force approach would be simply. I mean, the brute force for this is like pretty uh, right to the nose type thing, right? It's on your nose type thing. Let me try to solve this, right? And after that, I'll try to do some more. Right? Let me just delete all of this. I don't really want this. Clean slate. Done. Mm, so binary, given a binary array num, so an integer goal. So you are given, what are we given, sir? We are given an array which is binary, by the way, so let me take orange, right? Binary, binary array num. Binary array nums, right? So we got like 1, 0, 1, 0, 0, 1, something like that. And a goal is given. So we are given a goal, let's say 2, a number. So we need to figure all the number of subarrays. This is not the length of it, so number of subarrays. I mean, just cause like it's on the top of my mind. Let's say we can go through all the subarrays, right? We can see 1 as a subarray. We can go 1 0 as subarray. We can go 1 on 1 as subarray, and we can check the sum, right? We can check the sum. So for every subarray, you can check the sum, um, which is going to be n squared times k, cos O of n squared times k, cos n squared for all the subarrays and k for the, here is something like this, right? The sum, for the sum you have to at least like you have to do the sum again the subarray, right? Just to check whether it's a valid subarray or not. And if it's a valid subarray, we have to keep a count. So that is how the brute force would work, which I don't even want to write a solution of. So yeah, what would be another good approach? We want number of subarrays, by the way, sir. Number count slash count. Hmm, we can use sliding window if it's a subarray. That's it. In 1 0 0 1. Let's say this is our subarray, and our goal is 2, right? Goal is 2. And once you reach your goal, this is your subarray, a valid subarray. Let's also include another one. This is invalid, right? You can simply move your I to make it valid, and that's it. That's how it. Matlab, another the thought goes like this, right? Ki 1 0 1 0 1 uh 1 1 0 0 1 or something like that, right? And you want to know all the subarrays that actually make this. So first off, what I did was I have uh, made the subarray that right. Oh, we can do it like this. I mean, I don't know if this is the best approach. Move. Hello, let's go to this place. So the idea should go like this, right? The idea is 1 0 1 0 1 1 0 1 0 1, and goal is 2. The goal is 2. Um, so we need to figure uh, sub all sub arrays that has condition. What is the condition? The condition is the sum of elements is 2. Sum of the elements is 2. So what I came up with is to use the two pointer approach, right? 1 0 1 0 1 0 1 1. Let's say something like that, right? I need to figure all of what is the answer of this. Answer is 4. Answer up until here is 4. So let's just even like exclude all of that, and I'm gonna just say this is our thing, and this is I, this is J, right? Like basic simple two pointer approach. So what I'm gonna do is I'm gonna check every time a J is at a place, check if it's valid, valid or not. If it's valid or not. If it's invalid, invalid. If it's invalid, in the sense if the sum is not excluding goal, if the sum is smaller than goal, if the sum is smaller than goal, what I need to do is simply increase j, right? I will simply increase j. Yeah, I will simply increase j. I'm sorry, p. the j would come right here, right? Now, the sum still is smaller than g, so I would simply increase j, increase j. So this is where it would be. If the sum is equal to j, if the sum is equal to the goal, that's all right, that's good. Now we can increase the count. Yes, we can increase the count, right? And after increasing the count, we can increase the j too. So the count would be what? 1. Up until now, the count is 1. Now the j has increased and the sum is still reaching the goal. So I can increase the count to what? 2. And after this, we can increase the j value, right? J would come right here, and now what will happen is it will exclude exceeds, I'm sorry, it exceeds g, it exceeds g. What I want to do is like move I just a step, not until I'll see another one, because I want to count every other, because there are zeros, like let's say 0 1 0 1. So this is also a valid, this is also a goal reaching sub array, which I don't want to neglect. So I will just play this step by step, right? uh, this might be a little easy, I don't know, I'm just like thinking, but let's say, so what I will do is I will move, if it exceeds I will move I just another position. I'll just move I just another position. mm, and then check if it's like valid or not. If it's valid, then I increase the count. If it's like reaching the goal, then I'll increase the count. If it's not reaching the goal, if it's, let's say, if it exceeds, again, if this is 1, what I need to do is simply increase I. Yeah, because you don't want this, I don't know, man. Let's keep this at 0. I'll increase I right here, I and j, and this subarray is, you know rocks, this subarray passes, so I can increase the count again, and I'll move I to this space, and I'll check whether the subarray passes or not, and if this does, 101 actually does. That's another thing. So I'll move right here, and I'll check if it passes or not. It won't pass because the sum is 0. But how will I find the sum? It's by excluding the ith value, I guess. It's by excluding the ith value. Hello guys, can you hear me? No, takes. Let's go that. Hello, 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 hello. I guess you can hear me, I guess. Hello, Guru Prem. Oh, there it is. Hey. So I guess you guys got it right. What I'm trying to do right here. Hmm. Let me check my live. Where is my live? Hello, hello. Hel- Yeah. Hmm. All right, makes sense. Done, 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 done. This actually makes sense, right? I don't know how to write the code for this. but this approach at least makes sense. Yeah, okay. Whenever I move I need to subtract it from the sum. Whenever I move j, I need to add to the sum. Right. Let me just select all this. Let me delete the unlocked content. What do you mean delete all of that shit? All right. Hmm. Let me write solution again. Let me pick another pen in this time. What I want to pick. All right. Delete pen. Let me choose red this time. So I will go with 1 0 0 1 1 1 0 0, something like that. And goal is to find uh, all the arrays that add to 2, all the sub arrays that add to the number 2. All right, makes sense. Done. I and j should start right here. I and j should start right here. So my idea was I will run until j is smaller than size of the array. J is smaller than the size of the array. And the first thing that I would want to do, of course, at the end of the loop, I would definitely increase j. And the first thing I would want to do is to keep this maybe a variable called sum, and I would add to this thing, right? I would add the element that j is pointing to, right? I would definitely do that because j is something that eats into that subarray kind of thing, right? So I would maybe let me change the pen color because I feel like it, and I would want to use some blue here. And what I would say is, all right, uh, sum is equal to sum plus j, sum plus j. And now that sum has become 1, and now I would want to see, what I would want to see is, hello Guru Prema Kusu. Ah. All right, that makes sense. Let me just go through the process and I'll try to deal with like problems meanwhile, right? So yeah, j uh, j has taken in the sum. Now the sum has become 1. After that, I will check whether the sum equals the goal or not. If sum is smaller than goal, the sum is smaller than goal, eat more, bro. So what I would want to do is simply do j plus plus and continue, j plus plus and continue, or else I don't even want to write this, right? If the sum is smaller than j, I mean screw that, I don't want to even mention that. If the sum is equal to j, sum is equal to goal, I'm so sorry, if sum is equal to the goal, so which is now it is not, let's just suppose our j is right here, then our sum is equal to our goal, and what we need to do is increase our count, final count, right? Count plus plus, and which is good, and after that exit, matlab increase the j value. If sum is greater than g, I don't know whether to put this as a condition or a while condition. So let me just see. uh, there are two thoughts here, right? Let me try to explore both of them. If J is right here, let's just say J is right here and I is right here, and this sub array is invalid, right? You can't really count this, can't really count this. But what I thought was moving I one place at a time, one place at a time, moving I one place at a time and checking, मतलब adding them. So let's say I have moved. Let us think about writing this in while. While sum is greater than g, while sum is greater than g, what I would want to do is move I, right? Move I. Not just that, I'm gonna check the sum too. I'm gonna update the sum to sum minus I. So be ith is pointing. I wanted to decrease it by the sum and then check again. Do I need to check again? I plus plus. If it's equal to, if sum is equal to g, then increase the count. You simply increase the count and you increase the ith value too. All right. If that is if that is what's going to happen, let's just check what would that reflect. So let's just say this is I at first, and now that j has exceeded. Now that j has exceeded, I will start moving I. So while sum is greater than g, I sum minus I. So sum up until now is 3. So 3 minus 1 is 2. And if sum is equal to g, if sum is equal to g, which would which would be the case, right? Which would be the case if I exclude. Yeah, I simply increase the count of it. I simply increase the count of it, which would make the count up until now is 2. Count until now is 2. Let's say I'll write it right here. And after that, I plus plus, right? And what would happen is some um, this is again a valid one. This is again a valid one, right? But 0, 0, 1, 1 is a valid. Also, but 0, 1, 1 is also valid, right? 0, 1, 1 is also valid. 1, 1 is also valid. 1, 1 is also valid. I have this thought. I have this thought. I have this idea. You run the while loop until sum is smaller than g. Run the while loop. Once it exceeds, run the while loop until the sum exceeds, until the sum is greater than smaller than g. Because what will happen after that is 1, 0, 0, 1, 1. Now this is exceeding. But now once it is exceeded, it should count all the valid ones, because it shouldn't miss all the valid ones, right? So I will come, the ith one, or let's just say the left pointer is right here, and left pointer should check uh, and decrease the sum, which it will do, and the left pointer will point right. This one 0, 0, 1, 1. If if the, and at this point too, the sum would be sum minus 0, And also, if sum is equal to g, sum is equal to g, you can just simply count it up, right? You can just count, you can just increase the count, which will be like, yeah, 3. And if left comes right here too, the count will be 4. If it comes right here, be 5. And once the left pointer comes to this position, the matlab, the sum is not greater than g anymore, is it? The sum. Hmm. Hmm, hmm, hmm. Matlab, what I wanted to say was, run the loop until it is smaller than g itself. Until it, not while it's smaller than g, until it is smaller than or equal to g, run the loop. Can I say it that way? Just a second. Now, I will take 2 minutes of break, and after that, I'll come back again with fresh mind. I'll try to solve this in half an hour, and hopefully, I'll do some auth. At least half an hour of it. And I don't think auth really takes that much of time, right? Yeah. Bye. 3 minutes of break. Guys, I'm right here. I'm like trying to scribble something down in on my board. I don't know if you guys could see it. I'm trying to write it on that. Let me get to this conclusion. I really can't do it like in video or something like that. So yeah. this would make this valid, but we would just forget about 0011. Like equal to is valid is question that we are asking that if I take one off from the sum, is the count a valid one? Yes, it is. That's the case. I will just move ahead. So this would be the same here. If I take this off, would it be valid? Yes. Move. If I take this off, would it be valid? Yes. Move. If I come here, if I take this off, would it be valid? Seems like a problem. All subarrays are add to 2, right? At least the number, the counter. So I was gonna use I and J like that, while J is smaller. Right? So I wanted to, go through all of the array, right? J plus plus. But I still wanted to do. Is there a problem with this? J is smaller than array and J is getting increased at the end of every. I don't think there is. We need to find something. We need to go through all of the arrays, and we are using J pointer as like a mouse. That array. This J is right here. Every time I include the jth value, I'll check. I'll add it to the sum. If, if, the, if the sum is smaller, you don't even write the condition. You just increase your j, right? If the sum is smaller, you don't even write the condition. If the things get interesting if it's equal or greater. Well, you can just count. So thought was if it's just equal, I can just increase the count and eat more. Equal the count. It's the j plus plus, right? 0 0. Yeah, they would land something right. Yeah, they some gets added and it exceeds the code. It exceeds the code. So it's invalid. Now, if I eat more of zeros or ones, it won't make it valid, right? It would definitely not make it valid. So until now, we have figured a single valid subarray, and we have moved past the hit. A values right here and I values right here. We haven't really gone through the different, combinations of that valid subarray, which, which I was like trying to go after the exceeding thing, right? By moving the I should move I should move the left pointer. Not just while exceed, not just while it's invalid, but until uh, there is another zero here. This till is valid. What do I mean by this? I should move this until it's greater or equal. Until it's greater than or equal. So basically, what I'm trying to say here is 1 0 0 1 0 1. Let's say this is a thing. There is j here. Here is I. I want to check whether so it's the same thing, right? It's the mirror opposite of it. So I'm gonna subtract this from the sum and subtract this from the sum, and then I'm gonna check the count. If I could, you know, if I could just consider this, would it uh, would it be a valid subarray? Yes, it would, and the count would be increased, and I would actually go down, right? I would go down. So this, I so that this element 0 is now in trial. So we need to examine whether we could take this down or not, right? If we can take this one down, if I decrease this, would it be would it be affecting the whole sum? No, it won't. The count would be increased, and I'll increase the I too. So I don't know how to write this until equal to or greater. How will I write this? So I need to write something like while sum is equal to c, or while sum is greater than c. And also I need to write this if condition. If sum is no. The problem here is if I write something like this, I guess it would be running. Now, after it becomes invalid, only I need to run this loop. Guys, I need to cool down a bit. I can't really think. I'll take a break of a minute or two. I'll be right back.